Promoting Cognitive Development through Easy, Error-Tolerant, Playful Learning, presented by Nelli Khachatryan and the team, Anna Muradyan, Nelli Muradyan, Cema Barsagyan. Current state. Traditional preschool education has always placed a strong emphasis on teaching children to read, write, and perform mathematical operations from young age, since these are considered the main skills that are supposed to have the biggest impact on their academic success in future. Unfortunately, most public and even private early childhood education centers in Armenia still follow this logic and emphasize academic skills early without generally promoting cognitive development. The overall environment is rigid and teacher-centered, as you may see on the picture above that represents the traditional Armenian preschool. National standard as the main principle of preschool education considers the formation of cognitive interests of the child in various activities. Particular attention is paid to ensuring the quality of education at preschool age, which makes it necessary to find ways and means to developing cognitive abilities, taking into account children's needs and interests. Though the standard states the necessity in Armenia, public early childhood education institutions have not yet fully embraced the promotion of cognitive development through error-tolerant play and learning. In Indigami, we adopted play-based child-centered learning to develop cognitive processes in enjoyable and engaging environment. Further, we present activities we use daily to help develop cognitive skills in a playful environment. Why do we choose playful learning? Because play is vital to the intellectual development of a child. The role of play is for the child to understand better cognitive concepts in ways that are enjoyable, real, concrete, and meaningful for them. Playing comes easily to children. That's why many concepts are taught through play. This incentive serves as the foundation for the play-based learning approach, which uses as a setting for learning. Again, at the picture above, you see rigid, teacher-centered environment where children are passive learners. They are not engaged, they are not motivated to participate in any learning. At Indigami, children can explore, experiment, discover in a playful environment, in a pleasant and creative manner, rather than forcibly learn something. The ability to store and later retrieve information, to analyze and apply it to real-life situations, help them develop their executive function skills. Not only children learn lots of basic and fundamental information about the world, they are more likely to remember what they learned because it's concrete, personally meaningful, and motivational and engaging. Why we generally emphasize cognitive development at Indigami? Because we believe that cognitive development is the process by which human beings acquire, organize, and learn to use knowledge. This is a citation from Encyclopedia of Mental Health. Cognitive development provides children with the means of paying attention to thinking about the world around them. Everyday, colorful experiences, sensory experiences impact their cognitive development and enrich their experiences and gives a lot of ground for exploration and new knowledge to acquire. At Indigami, through playful learning, we develop the following skills that fall under cognitive development: logic and reasoning, memory, attention, perception, language and communication skills, critical thinking, evaluation and analyzing skills, ability to make comparisons, ability to explore and understand cause and effect, pattern recognition, problem solving, and much more. Our educators help enhance play-based learning by creating environments where rich play experiences and play-based activities exist. The qualitative data for this presentation has been collected by individual and group reports of the preschool educators who followed children's development and recorded it. They have been promoting cognitive development through easy, playful learning, but worked previously according to traditional academic curriculum. So they report positive differences compared to the previous year students who didn't, teaching whom we didn't use the same activities. The children are actively engaged in learning compared to the previous year's group. They apply the knowledge gained through play to their active lives in different settings. They are socially interactive, they are curious and motivated. Thus, the integration of play in the learning process positively contributes to a successful learning environment, promoting the learning process and therefore cognitive skills. The first activities we would like to present are activities with counting sticks. We start them at the age of 3 with very easy tasks to lay out a simple sequence, and then later an alpaca, cat, robot, rocket, whatever they like. First, they need to count the number of sticks in each figure. When they finish, then they can name the color of stickers they used. This activity develops fine motor skills, spatial representations, creative imagination, sensory mathematics, the child's ideas about form, quantity, color, and even quality. Because at the higher stage, we can suggest them to name all the geometric shapes that make up the figure, count all the shapes, count all the stickers they used. Next activity is generalizing categories, since categorization facilitates the storage and retrieval of information, and it supplies a principle of organization by which new information can be banked efficiently in memory. We may lay different objects of the same category on the table and ask children, what are all these objects together? Now let's separate them from others. For example, if we learn transport, we can separate nautical transport from road transport, or we can just separate all sea habitants from forest habitants. Alternative variant is showing pictures of some images that have similarities: wheel, steering wheel, pedal, or any other attribution of car or transportation. Tangram puzzles are hit. Our children love them. Tangram puzzles develop spatial relationships. Children learn geometric vocabulary and math concepts. They also become capable problem solvers, confident in their critical thinking skills. Children learn the properties and relationships of objects, arithmetic operations, a variety of geometric shapes. They develop an understanding of how geometric shapes can be composed. For example, a square is composed of 2 triangles or 4 triangles, and how they can be decomposed. Understanding the notions of big, bigger, and biggest, tall, taller, to tallest, can also be learned through tangram puzzles. Checkers is one of our favorite board games. We start learning playing checkers at the age of 4. Checkers develop the objectivity of thinking, diligence, purposefulness, accurate calculation. A year later, after learning to play checkers, children start learning playing chess. Activities that promote counting and reading are paired with creativity. For example, matching numbers with counters using dice and spaghetti while developing fine motor skills and while creating a hedgehog. Children use language to communicate, thinking about quantities to describe attributes. They demonstrate increasing understanding of measurement, number, using vocabulary to describe size, length. Learning literacy can be done through playing with puzzles. While playing, they are learning how to read. They learn abstract representations, that an object can represent something or someone else. Making meaning out of a jumble of letters and words takes the ability to reason abstractly. Next, pay great attention to matching and sequencing abilities. In the activity Find the Shadow, for a child to understand matching, they need to grasp the concepts of same and different. This particular activity develops abstract thinking, perception, attention. We start this type of activities at the age of 3. Next is sequencing and patterning. Seriation is arranging objects in order by size, location, or position. Ordering requires the ability to see differences and compare multiple objects. Patterning teaches children to predict what comes next. Patterns are found in maths, science, and many fields of study. Learning to sequence items and pictures from left to right helps children learn to read from left to right later, while developing spatial perception, attention, ability to analyze, match, and pattern. Playing with construction blocks is the most favorite pastime for our children. While playing with blocks, children boost creativity. They match, they count, they sort. Spatial reasoning provides understanding of how pieces fit together and encourages comprehension of different directions, shapes, and spaces. Block play helps grasp science concepts. Children learn about gravity, weight, stability, and balance as they build and explore. We have created 2-year special curricula for block building and STEM activities. Children develop early maths and number concepts. Problem-solving skills are at their best. Before they start building, they need to think what and how. Puzzles are the best way to develop attention, memory, ability to analyze, conclude, generalize, piece a whole from scratches, compose and decompose object. Puzzles develop memory skills as well as an ability to plan, test ideas, and solve problems. On the last pictures, you can see how children piece the puzzles together, create a doll, and also using their imagination and creativity, they draw, they paint their unique dolls. So we pair cognitive development with creativity. Children are constantly thinking, inventing, experimenting, and learning when they play. Our everyday activities are organized in child-centered environments for playful, implicit teaching that constantly emphasizes the development of cognitive abilities in emotional, error-tolerant environment. We believe that play and interaction are the best learning methods. Hands-on activities and ideas presented in this presentation, we hope will enrich educators' teaching and develop more effective teaching methods. Thus, the integration of play in the learning process positively contributes to a successful learning environment, thus promoting the learning process and therefore cognitive skills. Based on the interviews of educators, visual examination, and video recordings of children's play and engagement, we can say that children show full engagement compared to merely learning academic notions, suggesting easy, unaware, error-tolerant learning. By focusing on the development of cognitive processes, communication skills, and self-regulation mechanisms of behavior, it is expected that this will support children's future academic skills. Thank you for listening, and that's the end.